Hello guys, so thank you for watching this video. So this video is about the sample problems from 221 to 230. Okay, for this problem we want to calculate the ratio of standard deviation of company B's annual profit to the company A's profit. So we let B as y and let A as x, right? So we want to find this v sigma y over sigma x. We want to find this. So what is the x and the y? So this is x for A. X follow normal distribution. So mu. So y also normal distribution with the same mean, same positive mean. So it's about this sigma 1, and y follow this normal mu sigma 2. So we want to find a sigma 2 over sigma 1, right? Okay, so let's say so the condition is this: in a given year, the probability that the company B has loss is 0.9 times the probability. Okay, so this equal like a probability that y negative y less than 0 equal 0.9 for this probability, right? X less than 0. So there's a condition. Yeah, so from here we want to find, this ratio, right? So this is the question. Okay, so for those probabilities of this normal, so we say for normal we just convert the general normal to standard normal. So y less than 0 equals this probability, right? Z less than 0 minus mu over sigma 2. Okay, so this equal 0.9. So this probability becomes z less than, so negative mu over sigma 1. Right? Okay. So we don't know we don't know mu, we don't know sigma 1, sigma 2. So let's say whether we have other condition. Oh, so we need this condition, yeah. Okay, this is the standard deviation of company A is one half of its mean. Oh, so this means sigma 1 equal half mu. Okay, so based on this, so we can find, let's say, so what is, so we can find this, right? So 0.9 p, so this is z less than, so sigma 1 is half mu, so this equal negative 2. So we can find this probability, yeah, so this is easy. So this equal 0.9 multiply 0.02275. So this probability we can check from this one, we can check from the normal table. So we find this probability equal this, right? 205. Okay, the thing we know the less than this, like we know there's a cutoff point. We know the less than the cutoff point is 00205. So we can find this number from the table. Okay, so we find from the table, we find this number. This cutoff point is negative 2.04. Okay, so we get negative mu1 over sigma 2 should equal this negative 204. So this sigma 2 we can find. So then sigma 2 or sigma 1. So sigma 1 is half mu. So sigma 2 is 1 over 2 of 0.4 mu. So we can find this equal. So this is easy, yeah. So this equal like 2 over 2 of 4. Okay. So for this problem, we have moment generating function. So moment generating function of x is this. So from this moment generating function, we can know the distribution of this x. This x can be like 1, can be 2, can be 3, can be 4. And the probability for taking those values is here the 0.45. This is 35 and 15 and 0.05. So for find standard deviation of x, or find variance of x, so this is just a calculation, right? So variance of x is x square minus square x. Yeah, so find those just really simple. So the other way is we to find this, we also can from the moment generating function. This equal, we say the second moment is just second derivative of t, so we let the t equal 0. We also can use this, and then minus first derivative t equals 0. So this first derivative is just that, so this square. We also can use this way. So two way, which one is better? Almost the same. Okay, so for this problem, so we want to find the probability that this probability that the landing sample to average. Oh, the samples average. The landing samples average is between this. So this is just like x bar between size. So we want to find this probability. Okay, so we know x bar will follow. What is x bar? So x bar will follow normal distribution. Yeah. Okay. So what is this x bar? What is this? Oh, I'm sorry. here we also have x. Yes. So what is this x bar, y bar? Yeah. So let's check this. The claim amount x. This x with mean and standard deviation. So it's normal distribution. Yes. This x is normal distribution. So we say x is the claim amount for normal distribution. Mean is 100. So standard deviation 25. Oh, okay. Oh, this is in year 1. Yeah, in year 1. Then in year 2 is y. So y equal 1.04x plus 5. So this average of 25 claims in year 2. So this is y. So actually this is y bar. Yeah. So y bar. So we want to find this, right? The y bar between this range. So okay, so we have this like y bar follow this normal mu sigma over radical a. So this mu is y's mu. So what is mu? What is mu for y? So mu is just equal 104 multiplied mu for x. Mu x is 100 plus 5. So this is 109. So the mu is 109. So what is sigma or variance for y? Variance y is just equal 1.04 square Vx. Okay. So this this Vx variance, let's see. So standard deviation 25. So this equal. So we find this sigma for y equal 1.04 times 25. Okay. Okay. So now this problem become easy. Right? So this equal. So this y bar follow this normal. Mean is 109. And this sigma is 1.04 times 25. So this equal 109, and here is a little bit calculation, right? Divide by the 1.04. Let's see. But 5, right? Okay, so this is a 5.2. Okay, so now find. So this problem become from this normal distribution, like y bar follow this normal distribution. Then find the probability. So that's easy, right? So this less than 101, 110. So this is just changing to standard normal. Yeah. See, less than. So this minus 1 is 1 over 5.2. And so here is say negative 9 over 5.2. So we can check the normal table. So find this. So for this problem, we want to find exy. So this is like a double integration here. Exy. So we just according to definition, exy equal this, like xy f xy dx dy. Okay. So we just do this calculation. So this, so we need to find the integration region. So what is this region, and what is density function? So this is like x y are uniformly distributed on this region. So this region is says like, okay, x y and y equal 1 minus x squared. 1 minus x squared is this. Y equal 1 minus x squared. So here's 1. Okay, so we know this is region. Okay, so the density function fx is the constant. So this equal like a constant. So x, so 0 1 dx. So x from 0, here's 1. Then y is from 0 to 1 minus x squared. Then like xy dy. So those are just the calculation issue. Those are just the base, very simple one. So here just we should do this quickly. Okay, so let's say for this integration. So here x, so this y dy, so half y square, right? So this 1 minus x square is square. So this equal, so 0 1. So here, so expand this, so this become 1 minus x square is 1, so become x minus 2x3. So x plus x5, right? dx. So this integration is so here just the x, so x1 just become 1 over 2 minus 2. So here 1 over 4, so plus 1 over 6. Okay, so cancel this equal like c over 12. So then what is c? So we just use the same way. So c is this. Let's say we make sure this integration. So 0 1 minus x squared, yeah, dy. So we should multiply this c, this, we just let this equal 1. Okay. Okay, so this is just, let's say, c, this is 0 1. Just 1 minus x squared dx. So this is just very easy, right? So this is 1 minus 1 over 3. Okay, so we find c equal 3 over 2. So here we emphasize this, right? So 0 1 xk dx just equal 1 over k plus 1. Okay. So for this problem, we want to find expected number of tornadoes that result in fusing 50 million loss. So we want to find some random variable, right? So here x, y, so we want to find this number of tornado is X or Y. So this is X. This is the number of tornadoes that result in at least 50 million loss. And Y is total number of tornadoes. Okay, so here we want to find X. We want to find X. Okay, right? Calculate the expected number of tornadoes that result in infusing. Oh no. Okay. No. Yeah. So the infusing 50 million loss. So what is X? X is at least 50 million loss. So Y is total. So less than 50. Those actually is. I'm sorry. Those actually is total number minus X more than 50. So less than 50 is minus X. We want to find this. So here we can find what is X, that we can use X, Y minus X. Yeah, we can use Y minus X. So here, so we need to find this C, the constant C. So constant C is total probability equals 0. So here we have this X can be 0 to 0, 1. So 0, 1, 2, 3. Y also 0, 1, 2, 3. And we have this condition Y larger than X. So Y larger than X. So here, so Y larger than X. Actually, we have these points. These 3, like these points, and those points, and this point, and this point. Okay, we have those points. Okay, so we want to find so the probability together is 1. So we find that the probability is together is C. So just the summation X plus 2Y. So let's say that when X equal 1, or X 0. So we just when X equals 0, so Y can be from 0 to 1 to, so Y is 0, 1, 2, 3. Right? Okay, and plus X equal 1. So Y, so can be 2, X equal 1, 1, 2, 3. And so X equal 2. So Y is 2 and 3. So X equals 3. X equals 3. Y is 3. Right? So we find this equal 50. So this equals C times 50 equal 1. So C equal 1 over 50. Okay. Okay, so then we can find y minus. So here we can, so we can, let's say, so here we should be careful here. So this equal y minus x, but this y, we cannot say or just equal y, like y minus x. But this, so use this, maybe have some trouble, like, y minus x equal y minus x. Yeah, this is correct, but how to find this y? So y here is, we should consider this is two variable. We also involve, so for this y also involved for this x. So this, okay, so this way is not so good. So we can check this, like we just check y minus x. So here this line is y minus x equals 0. Minus equals 0 is this line, right? And this one we have 3 points. So y minus x equal 1. So here y minus x equal 2 and y minus x equals 3. So this expectation is just equal like y minus x equal 1 times the probability. So this probability is like just these 3 points, right? 3 points. 3 points. So these 3 points is, let's say, so 51 over c times, so we just plus, add them up. So this is probability is x plus 2y. So here this is x 0, y is 1. So this is 2, right? So this point 1 1, x equal 1, y equal 1. So this equals 3. X plus 2y is 3, right? So this one x equal 2, y equals 3. 2, 3. So here's the 2, 3. Okay. All right. So this is the y minus x equal 1. So we do not use this. We just use this. Okay. So plus y minus x equal 2. So 2, then probability that y minus x equal 2. We have this 2 points, right? So here this one is x equals 0, y equal 2. So this is 4, or 2y. And the other one is x equal 1, y equals 3. X equal 1, y equals 3. So x plus 2y. X equal 1, y equals 3 is 7. 1 plus 6, 7. Okay, so plus, so 3 times, so y minus x equals 3. So only 1 point. So this is x equals 0, y equals 3, right? So there's 2y equals 6. Okay, so this is just the y expectation for y minus x. So for this problem, we want to calculate the expectation of absolute value of the difference between the number of Republican and the number of Democrats. So this one, we just use this notation. We want to find the expectation of absolute value of Republic minus Democratic. Okay, right? We want to find this. Okay, so we just check what is the number for source R minus D. So this is like we have 10 waters. So we have 10. So we just split the 10. So among the 10, we have 3 are Republican and 2 are Democrats, and there's 5 are independent. So we just split this into 3 parts. So we just pick, we interview them, the pick 2 randomly. Pick 2. Okay. So we here I is the number of Republican, and D stand for number of Democratic. So we can say like so RD R can be the at the most it can be like a 2 or then 0, right? Or 1 or 0 2 or 0 0, right? So we have only there's 4 cases. Okay. Oh, I'm sorry. So we just check. Okay, also have this like this pick 1 and 0 and 0 1 can be like this, right? So so R minus D absolute value can be only this like 0 1 2. So for expectation 0, actually we don't care. So just 1. So this is just equal 1 times this probability plus this absolute value 2 multiply the probability. Okay. So when this equal 1's only 1 0 0 1, only these cases, only these 2 cases. Cannot be 2 1. Yeah. Okay. So what is this probability? So we say, oh, this probability is the 1 Democratic, no D. So this means like so totally is just from 10 pick 2. So we just pick 1 from Republican. So 3 choose 1, and then here choose 0. So then from independent pick 1, right? Okay. So plus, so here pick 2. So can be from 0 1 and 0 1 1. So from here pick 0. So from 2 pick 1 and 5 pick 1. Okay. So this is P1. Okay. So P2 is only these 2 cases, right? This one and this one. So P2 is also very easy. We just P2 so equal. So here 10 choose 2. So there's 2 2 0. So this means from 3 pick 2. Or other way is from 2 pick 2. Okay. Okay. So for this problem, let's say this is have joined the probability function is x. So here we say x and y. So x can take 0 1. For y can be 0 1 2. So, so, so we have 6 probability. So there's a probability we don't know. So here, suppose, okay. So only the condition we know is this. P12, 2 is P12 is 3 P11. So we put this as X. Oh, not is X. Yeah. If this is P, then this is 3P. And so this probability we don't know, this probability we don't know. Okay. So what is the condition for P? This is not X. Okay. So this is just those numbers we don't know. So the only condition is this one, maximize the variance of EY. So only condition this. So let's check what is the variance for E. What is the variance for XY? VXY. So equal EXY square minus EXY. Okay. So what is X square? So X times Y. So that's X squared. This XY equal. So X times Y can be, so this is 0. This 0 that can be on the not 0 is equal. This X, so 1 so this equal 1 square times P plus the 1 2. X equal 1, Y equal 2. 1 2 is the 2s of 2 square, then 3P. Right? So this is XY square. So minus XY. So XY is 1 times P. 1 1 plus 1 2. 1 2 is 2 times probability 3P. So there's a square. So variance for XY is this. So this equal, let's say, this is P, this is 213, so 13P, yeah, minus, so here actually 7P square, so 49P square. Okay, so maximize those things, we find P should equal, so we use P should equal this, right? We can use the derivative, or we can say, so for second degree polynomial, when it's taken maximum, so negative, we have the formula, right? B over 2a. So but anyway, we can find this is negative 2 times 49 over 13. Okay, so P equals this. Okay, so once we have this P, so what we want to find? We want to calculate the probability that X or Y equals 0. So this probability is, we want to find this: X equals 0 or Y equals 0. X equals 0 or Y equals 0. So this probability is just equal like a 1 minus, there's 2 cases, right? So there's not equal 0 only 2 cases. So there's equal P, 3P, just 4P. Okay. Okay. So for this problem, what we want to find? We want to find the average of this, giving that. So this is just a conditional expectation. So we want to find is so this one is y. So which one is x? So let's say first fraction appears the time first is, so this is for, let's say in here the x first one, yeah, x is first one, so y is second one. So we need to find average for y giving x equal 1/3. So we want to find this. Okay. So this x and y, their joint density function is this. So for such a problem, we just need to find the conditional density function for y. So we just put the x equal 1/3, right? So this is y, the density function for y. So we just put the x as 1/3. But this y should larger than x, larger than 1/3. Okay. But maybe this is not a density function. So we need to adjust it a little bit. So we can say this just equal k, some constant, multiply 1 minus y, and y is larger than 1/3, and y is less than 1. Yeah, y between 1 and 1/3. Okay. So we need to find this k. What is this k? Yeah. So this k, we want to guarantee this is a density function. So we have this, right? So let's say all integration. So fyk dy, this equal 1. So we need to find this k. Let's say, so this we put the k outside. So this integration 1, integration is 1 from 2/3, right? 1 minus 1/3. So minus y integrating half of this square, 1 square minus 1/3 square. So 1/9. Okay. So this one, let's see. So let's do a little bit of okay, simplify. So 2/3 minus half over 9, 8/9. So 4/9. So we can put this as 9. So this is 2, right? Yeah. So we can find k is 9/2. So we have the density function. So then what we need to find it easy, right? So find this conditional expectation y. So that's equal. We say this y when x equal this. So this is just is y. So density function is 9/2, 1 minus y dy, and the y is from 1/3 to 1. Okay, so then here just do those integration. Yeah. So let's say we take a constant outside. So then the integrations y integrated are the half of 1 minus this square, right? So minus y square is 1 over 3, so 1 square minus 1 over 3, oh, not square, cube, y square is, yeah, so this equal 27, like this. So this equal 9 over 2, so this is just some calculation. Half 9 over 8 minus 27 over 26. Okay, so this equal, we put cancel this 4, so this equal to, so it's just a math, yeah. So we use so 81, so this 81, so here 26, so here you multiply 9, so that's okay. So then this thing, so this become 5 over 9. So this problem, we need to take some time. Yeah, we at first we say what we wanted to do is calculate the expected number of severe storm that strike city J in a year during which five severe storms strike city K. So this is also the conditional expectation, right? So we want to find expected number of J. So we use J for, let's say this J stands for number of severe storm strike city J. Okay, so conditions when K, so K is same, right? K is severe, K is just the severe storms that strike city K. So when K equal 5, so we want to find those probability. Okay, so here, so let's check a condition. So condition is what? Condition, so we need to find this distribution for the conditional distribution for J when K equal 5. Okay, when J, we want to find this. So here so for J, we know J, this one follow binomial distribution. And mean n equal 5, yeah. So P is 0.6. So we know distribution for J. So for K, we only know the conditional distribution for K. We say if J equal M, then K can be, let's say, K can be M or M plus 1 or M plus 2. So here's when J equal M. Okay, and the probability is half. So this, we know there's a probability. So when J equal, when J is given, so here we know there's like the probability density function for probability for k given j equal m. We know this. So for this expectation, what we want to find is given k, right? Given k, we want to find j. Okay. So now let's say, so we want to find the probability. So we want to find those probability. Let's say actually we want to find those probability j equal j when k equal 5. We want to find this probability. Okay. So for this probability, so we can, like this is the conditional probability. So we need to find, so what is the probability k equal 5? So k equal 5, so we use the conditional probability. So j equal, we just say, so j equals j, k equal 5. Yeah. So this equal just bj equal j. And this under this condition, k equal 5. So we just check all the cases for j. So we can find so j equal, if j equal j, then k can be j, and it can be j plus 1, j plus 2, right? So we have this. So if we wanted to let k equal 5, so this j can be only 3, can be 4 or 5, right? So this actually we says j equal, so just equal j equal 3. So j equals 3, such a probability. So we can say only 3 cases. The j can be, so let's say j can be 3 and 4 and 5. Okay. So j equals 3, such a probability is 5, 3. So says p happens 3 and q happen 2. So if j equals 3, k equal 5, so this probability is this case, right? This case, like j is m, k is m plus 2 is, I think is 1/6, yeah, right? So this is 1/6. Okay, so then we say, oh, so we know when j equal 4, and j equal 4, k equal 5, so this probability is just the m to m plus 1 is 1/3. So this is 1/3, and then like, so k j equal 5, and then j equal k equal j, so k is also 5, so this is 1/2. Okay, yeah, so after calculation we found this number is this. Okay, so now how to find this probability j equal j. So for this one, okay, so let's see. So let's say we just check like when k equal 5, so this j can be only be 3, 4 or 5. So let's check this probability, like j equals 3 when k equal 5. So this equal pk equal 5, right? So here j equals 3, k equal 5. Yeah. So for this one, so we can only condition on j. So this equal pj equals 3. And under this condition j equals 3, k equals 5. And thus k equals 5. Okay, so these probabilities are equal. So we say j equals 3 is just this. Yeah, j equals 3. Okay, so j equals 3 is this probability. From 5 choose 3. 0.63, so 0.42. So this is j equals 3. So when j equals 3, what is the probability that k equals 5? So this probability is 1/6. Okay. So we find so this probability equal this. Okay. So same way we can find those probability, right? So j equal 4, k equal 5. So use the same way, and so we can find like j equal 5 when k equal 5. Okay, so then there's expectation for j when k equal 5. So this is just equal. So j equals 3, right? Multiply this probability. So j equal 4, multiply the probability. So j equal 5, multiply the probability. Okay. Now, so this problem is a little bit tough, right? So here the idea is we need to change the condition like this. If the condition is we just like that, we have this condition, but the question is we want to find those probability, right? Yeah. So here we need, in order to use this information, we should use this like PA. So then this is P A B and A. So we should put the yeah, we wanted to find P, so A and B, so we need to find PB first. Yeah, PB, then like this. Alright, so we just use those idea, changing the condition, changing. So this actually in probability we call this is Bayes' formula. Yeah. Okay. So then last one, 230. So this is joint cumulative distributive function. We have this. Okay. So and what we needed to find expected value who will choose to be covered on both. So what cover on the both planes? So what is this, x or y? Oh, we find so x is, what is x? Yeah, X only covered by medical plans. Y is covered on both. Okay, so we want to find EY. The problem is find EY. So the condition is we know if XY, from here we want to find EY. So to find EY, so we need to know density function of Y. So we want to find Fy. So here we have a cumulative function. So so here we have joined cumulative. So what is, let's say, so what is Fy? So here the question, the idea is we this one we just equal, we let x is infinity y. Okay. So now let's say what is Fy? Fy is according to definition this, like probability y less than y. So for x we no condition. So what is Fxy? Xy is this probability, right? X less than x, y less than y. So if we let this x equal infinity, so this probability just become y less than y. Okay. Okay, so this is the idea. So let's say, so what is, so we just pick x largest. So here, let's say, x, so we just put the x, largest x here is 1. Okay, so we just plug in x as 1. So we know, we have this, so Fy equal, we just plug in x as 1. So 1 plus y minus y squared. And the range for y is between 0 to 1. So we find when y equal 1, this is 1. Yeah. When y equals 0, this is 0. So this Fy is cumulative function. So density function, so just a derivative. Okay. So we find density function equal 1 plus 2y minus 3y squared. Okay. So by now, EY is very easy, right? So now is easy. So here there's an example, there's a problem just from cumulative function to expectation. So just from cumulative to density function, saying from density function we can have everything, right? So this equal, so y times, so now this problem become easy. So we should do quickly. Yeah. So y integrate out 1 over 2 plus 2. So y square is 1 over 3 minus 3. Y3 is 1 over 4. Okay. So then, okay, so let's stop here. So this is a problem from 220 to 230.